Welcome to Amagerværket Power Station. This tour will introduce you to our new biomass-fired power station AMV4 and show you how it can help reduce the CO2 emissions that come from heat and electricity production for our apartments and houses. We start here at the delivery of the biomass that provides energy for the power station. This ship has just arrived with the delivery of wood chips. Each year, AMV4 consumes approximately 1.2 million tons of wood chips, and therefore 200 to 300 ships arrive annually with a cargo full of biomass. The wood comes from sustainable forestries who have surpluses of low-value wood. That may, for example, be branches, sawdust, or rotten tree trunks, which are not suitable for other uses. For many years, electricity and heat have been generated by burning coal, but it's become increasingly clear that the fossil fuels are damaging Earth's climate. By burning wood chips in AMV4 instead of coal, CO2 emissions are reduced by 80 to 95%. This is crucial for achieving Copenhagen's goal of CO2 neutrality in 2025 and for creating a climate-friendly Greater Copenhagen. HO4 ensures that the biomass only comes from certified suppliers who plant new trees every time we buy wood chips. This is important, otherwise biomass would not be the sustainable energy source that it should be. Wood chips contain less energy per mass than coal. Therefore, huge amounts of biomass need to be stored at Amagerværket. Together, these two storage facilities can hold more than 100,000 cubic meters of wood chips, equivalent of 100 filled swimming pools. However, this is only enough for about a week's consumption at AMV4. Therefore, new wood chips must be constantly supplied to continue the production of heat and electricity. When the wood chips are needed, they're moved on long conveyor belts to the boiler for burning. We follow the biomass on its way to AMV4. The most important job for AMV4 is to produce hot water for the district heating network. In Copenhagen, more than 98% of the buildings are connected to district heating, which makes the Danish capital a world leader in the field. The construction of such a district heating system has required many years of visionary planning to integrate everyone into the system, and with AMV4, the district heating is now becoming greener than ever. A very special technique is used to combust the biomass, so-called CFB combustion, which is short for circulating fluidized bed. The principle in CFB is that the biomass is combusted in a hot sandstorm, which is sustained by huge fans that pump air through the bottom of the boiler. The sandstorm ensures that the wood chips are burned homogeneously, even though the pieces of wood have different humidity, shapes and sizes. The sand is recycled in a circular process, while the flue gas from the burned wood continues on in AMV4. The biomass is combusted in order to heat water to obtain hot steam at a high pressure. The steam can be used to power a turbine, which is connected to an electric generator. Thus, the heat energy from the wood chips is converted into an electric power production of 150 megawatts. However, the steam is mainly used to heat water for the district heating network, and in fact the turbine on AMV4 can be completely switched off so that the plant only produces heat. In this case, it can produce up to 585 megawatts of heating. AMV4 is managed from the control room, which is manned around the clock, also on Christmas Eve. The energy production is constantly adapted to society's needs, so that there is enough heat and electricity for the consumers. In Denmark, there's often a lot of electricity available, for example because of wind turbines. Therefore, it's advantageous that AMV4 can stop its electricity production to only produce heat for the district heating network. AMV4 is not just built to produce electricity and heat. It's also built to minimize the environmental impact of the flue gas from the biomass combustion. Before exiting the chimney, the flue gas undergoes a series of cleaning steps that remove dust and environmentally harmful substances. Furthermore, so-called flue gas condensation is used to capture the residual heat from the flue gas, so that a minimum of energy is wasted. The gas coming out of the chimney has a temperature of only 36 degrees Celsius. The rest of the biomass energy is used for district heating and electricity. The chimney also emits CO2 during biomass combustion. But most of this CO2 is absorbed again when new trees are planted in the sustainable forestries. This biomass cycle is not completely carbon neutral, but it's far more climate friendly than the alternative of burning coal. In the future, HO4 aims at using new technologies for a totally CO2 neutral production of electricity and heat. But until then, AMV4 is an important stepping stone on the road to a climate neutral Greater Copenhagen.